Hello guys, welcome to my channel. This is Learning Ramen and I believe that every student deserves to learn math at their own pace. Today, we're going to learn about simplifying rational algebraic expressions. But before that, let's go back to the prerequisites of this lesson. We have simplifying fractions, law of exponents, factoring, and integers. If you already mastered these prerequisites, you may advance to the next slides. To simplify fractions, we need to make sure that there are no more common factors in numerator and denominator. In our first example, 3 out of 6, we can say that the numerator can still be written as 3 times 1, and the 6 can be written as 3 times 2. And here, 3 is still common in both numerator and denominator. So if we cancel that out, it will give us 1 over 2, which is the simplified form of 3 over 6. For our second example, we have 4 times 5 over 4. 4 and 5 are already separated by multiplication, or they are called factored out. Therefore, we can cancel the 4 right away, and it will give us 5 over 1, or 5. And that's the simplified form. For our example number 3, we cannot cancel the 5 right away here because they are still separated by plus sign. So what we're going to do is we're going to factor them out first or separate them by using a multiplication. But how are we going to do that? If you can remember your factoring of GCF, then we can see that 5 is still the GCF of 10 and 5. So we're going to rewrite it as 5 multiplied by 2 plus 1 over 5. Now that we separated the 5 out of the 10 and 5, that's the time that we can cancel them out, which gives us 3 over 1 or 3. And these are the common simplifying methods that we're going to use in simplifying rational algebraic expressions. Now here, we have our first example in rational algebraic expressions, x over x squared. To simplify this one, we need to rewrite our numerator as x, but in the denominator, we have an exponent of 2. Then we can rewrite it at x times x. And we can see that there is a common factor of x on the numerator and denominator. So x divided by x, that would be 1. And that will give us 1 over x. Or based on your law of exponents, we can also do the subtraction of exponent, wherein the smaller exponent is subtracted from the greater exponent depending on which it is located. So since the greater exponent is located in the denominator, we can subtract the exponent in the denominator, which gives us x raised to 2 minus 1. And what is left on the numerator is 1. Then that will give us the same answer. For the second example, we have x times y over y. And we know that the numerator is already in the product form. That means they are already factored out. Therefore, we can cancel the y, or what is common on numerator and denominator, right away. And it will give us x over 1. Or we can just write x. And applying what we have learned from the previous slide on the problem number 3, remember that we cannot cancel the y yet because they are not in product form or factored out form. So let's factor out the y in both xy plus y. So we can rewrite it as y multiplied by x plus 1 over y. If you still need to review about the factoring of the GCF, you can revisit our video. Just search factoring the greatest common factor by Learning Ramen. Now that we have separated the y out of the xy plus y, we can cancel the common in numerator and denominator. And that will give us x plus 1 over 1, or x plus 1. And those are just some of the examples of rational algebraic expressions. And let's have some more examples. Here we have 18a cubed times c over 12a squared times c raised to 5. I provided a multiplication table in case you might need it in finding the factor of our numerical coefficients. Now let's write the factors of 18 and 12. For 18, we have 1 times 18, 2 times 9, 3 times 6. And for the 12, we have 1 times 12, 2 times 6, and 3 times 4. And we can notice that 6 is the greatest common factor. So we will going to rewrite our numerator and denominator based on those factors. So we have 3 times 6, a cubed times c. For the 12, we will going to rewrite it as 2 times 6 times a squared c raised to 5. And here we can cancel the greatest common factor, which is 6. And in terms of a, we can cancel the a squared subtracted to 3. That would be 3 minus 2 will give us 1a. And here we have 1c and 5c. So that would be 5 minus 1 will give us c raised to 4. So we can write our final answer, 3a over 2c raised to 4. And that's our simplified form. For question number 5, here you need to revisit your factoring of trinomials or factoring of difference of two squares. For the numerator, we're going to factor this out using the factors of 16. Minus 16, the 16 and find the factors of it. 1 times 16, 2 times 8, 4 times 4. Since there is no middle term here, we need to make sure that the difference is 0. So 16 minus 1, 15. 8 minus 2, 6. 4 minus 4 is 0. So therefore, we're going to use these factors. Since we are aiming for a negative 16, one of which will have a negative sign. So you can choose between those two. Now, in my numerator, I can rewrite it as x plus 4 multiplied by x minus 4. For the denominator, we have x squared plus 10x plus 24. Here, the last term is 24. So we will find the factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And since it's positive, we need to find the sum. 1 plus 24 is 25. 2 and 12, we have 14. 3 and 8, we have 11. 4 and 6, we will have 10. So since 10 is the middle term, we're going to use these factors. So we have x plus 4 multiplied by x plus 6. And we will not have any negative sign here because the 24 is positive. Now that we have factored out the numerator and denominator, we can see that x plus 4 and x plus 4 is common. So therefore, your final answer is x minus 4 over x plus 6. For number 6, we're still going to use the same method. We're going to factor out the numerator first, then followed by the denominator. So for the numerator, we have x squared plus 7x plus 12. And the factors of 12 are 1 times 12, 2 times 6, 3 times 4. And since it's positive 12, we need to get the sum. We have 13, 8, and 7. The middle term is 7, so we're going to use these factors. Then we can factor out our numerator by using the factors x plus 3 and x plus 4. For the denominator, we have x squared minus 7x minus 30. And the factors of 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. But since it's negative, we need to get the difference. We have 29, 13, 7, and 1. Since we have negative 7, we're going to pick these factors. And since it is negative 7, the negative sign goes to a bigger number. So 3 and negative 10 are the factors. Let's write them inside the two parentheses. X plus 3 and x minus 10. Now, x plus 3 on the numerator and x plus 3 on the denominator, we can cancel them out. And that will leave us our simplified form, which is x plus 4 over x minus that. For the last 3 questions, you can try this on your own and be the first one to comment the answers below. I hope this video helps you to be more confident in simplifying rational algebraic expressions. Thanks for watching, guys.